So we're going over to standard 1 today, and you'll see they're called strands, but a lot of the standards have more than one strand, whereas standard 1 only has one strand. So today is a lot shorter than what the next standards will take. But like standard 2 has 3 strands, standard 3 has 4 strands, and standard 4 has 4 strands. Okay? So standard 1 is the inquiry of the nature of science and technology, a lot on the scientific method and just laboratory procedures in general. And the 8 to 13 question means that on the actual test, you will have 8 to 13 questions from the standard. I think it's a 2-day. 2-day test. Yeah.
When is this?
April 1st, I think, for science. 1st and 2nd. You will take it in the classroom. You'll take it in here. If it takes you longer than one period, you can keep working. There's no time limit on it. Not the whole day, probably. It shouldn't take you the whole day. So the standard 1 states, students will design and conduct investigations that lead to the use of logic and evidence in the formulation of scientific explanations and models. And then they have these A through, I think, H on this one that are different ways that you can demonstrate that you have met that standard. So we're going to go through those. So A is formulating a testable hypothesis supported by prior knowledge to guide an investigation. So what is a hypothesis? Educated guess. So based on knowledge, based on previous knowledge, you make a statement saying why this is happening, and then it has to be able to be tested. So you are going to do an experiment to test that hypothesis. You take observations. Well, really before and after. Your observations before help you make that educated hypothesis, and then afterwards the observations are in the experiment. So what the observations you see as you're testing it. B, design and collect logical and sequential scientific investigations with repeated trials and apply findings to new investigations. Important there, repeated trials. You don't want to just do one trial in case your instrumentation is off or you do something wrong. You want to do repeated trials to decrease the chance of error, and then you usually take the average of them. What's the difference between control group and experimental group? Control stays the same, and it's what you're comparing the experimental groups to. So control group is under normal conditions, and then you're changing a variable for the experimental group, and you can compare it back to the control group. You forget which one? What? Ooh, we'll talk about that one. Yep, that's a big one. And then what's the difference between qualitative and quantitative data? Yep, quantitative has quantities, they're numbers. Qualitative are just like color, changing color, or like on your flame test, observing the color of the flame. That would be a qualitative data. Still important data, but it's just not numerical. Okay, C. Identify and manage variables and constraints. This is where we get the independent and dependent variable. So the independent variable is the variable that you manipulate. So you are changing that variable, and then you're measuring what happens to the dependent variable based on what you did to the independent variable. Yes. Now both of these would change. Both of them are changing, so neither of them are in the control group. Well, they would be, but they're normal conditions. You don't change them in the control group. Those would be the variables that you're changing for the experimental group. We'll have some sample questions in a little bit. Select and use lab equipment and technology appropriately and accurately. So what do you measure mass with? Lab equipment. Balance, yep. And we use the triple beam balance, or we have the electronic balances when you use the balance. What about volume? No. No. Graduated cylinder. Let me get this cylinder. If you were to measure out 10 milliliters in a graduated cylinder and then poured it into a beaker, it probably would not read 10 milliliters. The beakers are very rough estimations. They aren't built or produced to measure the volume. It gives you a rough estimation. There's also what's called a volumetric flask. Do you guys know what a volumetric flask looks like? It's that one with the really skinny neck. Here, let me grab one here. They look like this, and they only measure one volume. So this one can only measure 100 milliliters. You can't measure out anything else other than 100. So you make solutions a lot of times with these. You would fill, and you see this little glass etching on the neck. As long as the bottom of the meniscus is right at that glass etching, it's exactly 100 milliliters. Exactly. What about temperature? What do you use? Thermometer. What's the SI units for temperature? No. Kelvin. Remember gas laws? We had to use Kelvin. That's the SI unit. Celsius is what we use a lot, and that's what our thermometers measure, but that is a metric unit, but it's not the SI unit. Microscopes really don't measure anything. They would just enlarge. They measure stuff. What do they measure? And then the stopwatch measures time. Okay, using tools and technology to make detailed quantitative and qualitative observations. What's parallax? You remember from the beginning of the year? What?
No, it's light refraction.
Well, yeah, so it's error produced from your point of view. So where should you look at error from point of view? Because where should you look at a graduated cylinder when you're measuring something out? Eye level. Eye level. So you don't want to look from the top or the bottom or at a different angle because you'll get the incorrect measurement. Kind of like when you're in the passenger seat and you're looking over at the speedometer, as long as it's not a digital one, you read the same speed as the driver? No.
Parallax.
That is an example of parallax also. What are the units for? Well, the metric units, the SI units, we want to use what's called the MKS system for SI units. Meters, kilograms, and seconds. Everything should be based on the meter, kilogram, and second. That would be your SI unit. I'll put 4 SI units. We can have derived units from that. Remember, derived units come from a mixture of those. So what's the SI unit for volume? No, not a milliliter. Has to be based on these 3 units. It'd be a meter cubed. Meter cubed, because volume is a length times width times height. And if we're measuring the lengths in meters, it'd be meters cubed. Now we do metric system Milliliters, liters, those are all part of the metric system, but they are not SI units. We use the milliliter and liter a lot. Like, what would be the SI unit for density? It'd have to be kilogram over meters cubed. That would be your SI unit. Now, we use grams per milliliter, different units for density that are metric units, but the official SI unit would be the kilogram per meters cubed. So just being able to tell what the difference between metric and English for sure would be important. So like feet, miles, those are not units that we would want to use. Okay, graphs and tables are good ways to show and dictate show the data that you get. What are some different types of graphs? Pie, bar, line, scatter, I heard. Telegraph. Those are probably the most used. We probably use the line graph the most to show data. Remember, line graphs, you would want force. Let me think. You would want the independent variable on the y-axis and the dependent on the x-axis. So I'm just thinking of force times acceleration, or like our equation, F equals ma. Force is something that you control. You would push a cart with the different amounts of force, and you would measure the acceleration. The different amounts of force that you're applying would be your independent variable because you're controlling it. So it would want to be on the y-axis. And then the x-axis would be the acceleration that changes based on your amount of force. Now, if we have a linear graph that looks like this, we could solve for the slope, and it would be rise over run.
What would be the perspective?
It is a right triangle. What would this equal? If we have this equation, this is equal to the slope. And for this equation, it's a constant. Our constant is mass. So in this, for this example, we're graphing force versus acceleration. And if it's a linear relationship, that slope would equal your mass of the object. Constant. Okay. Analyzing and interpreting data, synthesize ideas, formulate and evaluate models, clarify concepts and explanations. So what's the difference between a theory and a law? What you think will happen? It's been tested. You continue testing it and you're adding more and more data to it for a theory. It's testable. You're continually testing it and adding more data. A law is usually an overlying principle that explains several theories together. Right, you're still always testing it, but it's pretty set in stone. Not that it can't change; it could still change. A lot of times a law will have a mathematical equation that accompanies it. It will kind of have a mathematical equation that relates all those theories together. Okay. Use results to verify or refute a hypothesis. So you make a hypothesis and you do your experiment on it and it does not agree. What do you do? If your data does not agree with your hypothesis. Form a new hypothesis and retest again. Yep. If it does agree, if your data does agree, if your results do agree with your hypothesis, then you can share your information, procedures, results, and defend findings to the scientific community. And that can be your peers, whether it's in our class here, peer-reviewed journals, like the American Journal of Chemistry would be, you submit articles, submit your findings, and then there's a panel of scientists that would review that and test it for accuracy and different qualifications to be published. Science fair projects. Do you guys do science fair projects?
Wet water law.
What?
The water's plants up high. Yeah, I did science fair.
And what was it?
The wet water law. Adam Miller and water plants. They're in hard to reach places.
Ah,
And it actually worked. We got 30 minutes.
nice. Okay, the last two, using investigations to offer revisions and new ideas. So you may have results that will change. There's been several, like in the atomic theory, there were new results that changed that atomic theory. It's always changing based on what findings are discovered. And then using appropriate mathematics in all aspects. So grab your clicker. Yes.
Oh, come on, Natalie. What are you doing? Think just because you're better dressed than I am, you can just do that? Okay.
Is this just practice or?
How long did it take you to get dressed this morning? He had waist first period. I'm like, why did you not wear this morning? Why the Lord put it on?
Okay, here's your first question. What piece of lab equipment would you use to accurately measure volume?
Start the question.
I think I might fail.
I did start the question.
Chill out.
Join code is 65. I know, you haven't sent it. It hasn't received yours yet. There we go. Answer is
I was trying to. It wouldn't put
Trey.
It was on my other old pen.
Answer is C. Yes. Okay, here's your new one. Student wants to design an experiment to determine the effect of temperature on the rate of chemical reaction. What's the dependent variable? I can't read it. It looks hard to read on your sheet. Okay, answer is, we have some widespread answers here. B or C, the correct answer is B, yes. So dependent is the thing you're not manipulating, but it's changing based on what you're manipulating. So the student is manipulating the temperature, right? Changing the temperature and then measuring the rate of reaction. So the temperature would be the independent variable, and the rate of reaction is the dependent.
So an independent is what the student controls,
Mm-hmm.
and the dependent is something that's changing, but it's
You aren't really. It's because of what you did. Okay, in the metric system, the labels for units for volume could be which one of those? It's on the back of your sheet, too. Volume. And it's just the metric system, not SI units, metric units. Answer is B. Yes. So A has a gram in there. Is gram a unit for volume? No, it's a unit for mass. So A can't be correct. C is all volume units, but they're all English units. And then D is all grams. I think they're called the English units. Mm-hmm. There's only 3 countries that use the mile and the English units. It's us, Burma, and Liberia. Yeah. So we should change to metric. It would be so much easier too. It'd just be really expensive. You meant all the signs and maps and. Mm-hmm. What must be true of a hypothesis to be accepted in science? Who's number 4? Answer is B. Must be testable. Observable, yes, but that's part of your testing and measuring it. Also, well, actually, you don't need to be able to measure it. You could just make color observations or something. That's not really measurable. So, it must be testable of some sort. Okay, a student pushes a cart with a mass of 2 kilograms at 3 different levels of force, 5, 10, and 15 newtons. Student measures the time it took the cart to travel 3 meters for each force. What is the dependent variable? We'll take the quiz in the actual program. Answer is A. It is. So the student is manipulating and changing the force. So the force is the independent variable. And then what is changing? He's measuring the time. So the time is the dependent variable. Now, you could have had a different experiment where maybe instead of measuring the time for a specific distance, maybe it gave you a specific time, like in 5 seconds, how far did it travel? So then distance would be your dependent variable. So it can change based on what your experiment is doing. And I think that's it. Yep.